In this video, we'll discuss how do we approximate integral. Why do we do that? The reason is no matter how many techniques on evaluating integrals, there are always more integrals. You have no idea how to integrate, right? All the techniques fails. So, but in the applications in engineering or physics, we don't need to know the exact value of integral. So we want to know how do we approximate it, right? Suppose the integration exists, how do we get a reasonable estimate of this number, right? So we know that if the limit exists, so then the limit is as n goes to infinity. If the integral exists, the integral is as n goes to infinity, f of xi times delta x summation I from 1 to n, right? For sure, one good approximation is you choose a very large n, right? Then you just calculate the sum of this finite sum, right? And that's a good approximation, but sometimes that's not very efficient. So you can choose different sample point to get a better approximation, right? One way to do that is choose a middle point, right? So if you have the interval xi minus 1 to xi, so we choose the middle point of that. So the midpoint of that is what? The sum of these 2 points divided by 2, right? So we choose the middle point. That will give you a better approximation, right? This is called the midpoint rule. Depends on the function. This in majority of time, fix the number n here. This is giving you a better approximation, right? The integration from a to b, f of x dx can be approximated by summation I from 1 to n here, f of xi bar, where xi bar is the middle point of the interval from xi minus 1 to xi. So that should be 1/2 xi minus 1 plus xi, right? Then times delta x. So this is the right side is basically delta x is a common factor times f of x1 bar plus all the way to plus f of x n bar here, right? Okay, so here we should know that xi is a plus I times delta x, right? And delta x is b minus a over n. And xi bar is 1/2 xi minus 1 plus xi, right? So this is a good way to approximate a definite integral, right? If you have no idea how to evaluate an integral, this is a good way to do that. So let's see a example, right? Let's see an example. We want to use the midpoint rule to estimate the integration, which is integration from 0 to 2 x over x to 4 plus 1 dx, right? With n equal to what? N equal to 4, right? So let's try to approximate this definite integral. Use the midpoint rule with choose n equal to 4, right? If you choose the right endpoint, you might have a not a good approximation. So we want to use midpoint rule, right? So what you do here is for sure, you divide n here is the number of subintervals you want to divide 0 to into, right? So we have 0 to 2, which is our domain. Our n here is 4, right? You just divide it into 4 intervals. You get this is x0, x1, x2, x3, x4, x4, right? x1 is 1 over, no, 2 over 4. x2 is 4. x2 is 2 times 2 over 4, right? 4 over 4, 6 over 4, and 8 over 4, right? Now you want to know what's middle point. Middle point is this point, x1 bar. x1 bar is 0 plus 1/2 divided by 2, right? So this is x1 bar. Okay, I'll just put it in the bottom, but let me label that on this picture here. Then x2 bar, x3 bar, and x4 bar, right? So x1 bar is 1/2 x0 plus x1. So this is 1/2 0 plus 0 plus 0 0 plus 2 over 4, right? If you try to evaluate it, this is 1 over 4. x2 bar is 1/2 2 over 4 plus 4 over 4, right? If you try to calculate it, and this is 0.25, and x3 bar is 1/2 x2 plus x3. So this will be 1/2 4 over 4 plus 6 over 4. So this is 1.25. x4 is 1/2 x3 plus x4, which is 1/2 6 over 4 plus 8 over 4. So this is 1.75, right? We get all the middle points. So integration from 0 to 2, x over x to 4 plus 1 dx is what? It can be approximated by f of x1 bar times delta x plus f of x2 bar times delta x plus f of x3 bar times delta x plus f of x4 bar times delta x. We know the function, right? And so this is 1 over 4 plus 1 over 4 to the power 4 plus 1 times delta x is 2 over 4, right? We know that delta x is 2 minus 0 over 4, so this is 1/2, right? Then times 1/2 plus x2 bar is 0.75 over 0.75 to the power 4 plus 1 times 1/2 plus 1.25 over 1.25 to the power 4 plus 1 times 1/2 plus 1.75 over 1.75 to the power 4 plus 1 times 1/2. So this is how do we use the midpoint rule to estimate the value of some definite integral.